Right, grade 11's on to question 5. Question 5 was actually taken from a matric past paper, and it was quite criticized at the time for one reason only. It's a lovely question, but the question says the diagram below shows g of x, which is your hyperbola, with asymptotes at y is 1 and x is minus 1. Now, if you look at your graph, you're kind of like, okay, well, where are the axes and where's the asymptotes? There's too many solid lines. And for some unknown reason, they never actually drew this asymptote. I should draw it next to it so you can see it. This is actually an asymptote. They decided to draw it with a solid line, which was quite bizarre. They generally don't do that, and they haven't done it again. But if you ever were being thrown by this in an exam, highlight them so that you can actually see them as asymptotes. Not too sure why they did that. Okay, then it also says the graph of g intersects the x-axis at t, so now you know that's an x-intercept, and you know that 0, 3 is where it hits the y-axis. The line y is equal to x intersects g at s, so that's a point of intersection. Right, let's have a look. Write down the values of p and q. Now that's a different type of question to find the equation of. They're actually going to give you marks for saying p equals and q equals. Well, let's look at the graph. The graph g of x is equal to 2 divided by x plus p plus q. Now this is a pretty sneaky question because of the fact that they put a plus in the formula. We normally default to have a minus there, but so this can be a bit off-putting. So what I would first do is I always write down what I know the equation to be. This graph moved 1 unit left, so I know the denominator must be x plus 1. It also moved 1 unit up, so it must be up 1 unit. So don't forget, if you move left, it's actually plus 1 in the formula. Now, that's not what they wanted. They wanted to know what is the value of p and what is the value of q. So if you see that the formula is x plus p, and I now know that this formula is x plus 1, I can tell you that p has to equal 1. It doesn't have to be equal to negative 1 simply because they had a plus in the formula which they gave you, and you have a plus in the formula which you know the answer is. And so p has to have a value of just 1 in order to make this work. I can also see that q has a value of 1 as well. Okay, so just be careful of the signs. You never actually know the signs by looking at a graph because it depends on what the default formula is that they gave you. Right, 5.2 says calculate the x-coordinate at t. Careful, it just says x-coordinate, so I don't actually have to write it as a coordinate. I just need to know my x value. Now that's an x-intercept. So at an x-intercept, y is equal to 0. So if I take my hyperbola that I've just worked out the answer to, and I prefer to get one term on either side so that I can multiply both terms by x plus 1. So that multiplies by x plus 1 and it cancels. This is going to multiply by x plus 1, and so I get negative 1, x plus 1 equals 2. And if I go over next door, that gives me negative x minus 1 equals 2. So negative x equals 3, and x be equal to negative 3. And again, they didn't say a coordinate, they said the x-coordinate. So x is minus 3. Now just have a look at that. Does that look plausible? Yeah, it does look plausible. It has to be less than negative 1, and we don't draw to scale, so that looks about right. Okay, now it says write down the equation of the vertical asymptote of h, and h is a new graph. H is defined by g of x plus 5. So what transformation happens if you take x, and instead of writing x, you write x plus 5? Now we should know by now that that's a translation 5 units left, because it's plus 5. And so if I go to the graph, basically they're telling me that this g of x is moved 5 units left to form h. So if everything is moved 5 units left, my asymptote will also move 5 units left, and I will get my asymptote happening at x is equal to negative 6. So if I scroll down, that was the answer to my question. Write down the equation of the vertical asymptote of h, x equals negative 6. Now you don't have to show any working. You can see it's only worth 1 mark. This is your working in your head, and then you can look at the graph, but you don't actually have to explain at all. Right, this was a very interesting question. This question said, can you calculate the length of OS? Now, these matrics would never have seen this type of question before because we do a lot of vertical distance questions, we do a lot of horizontal distance questions. We've never done a question like this, where this isn't horizontal and it isn't vertical. It's diagonal. Now, if you remember grade 10, there's something called the distance formula. Now, it's on your formula sheet, and so as long as I would know the coordinates of S, I could actually use my distance formula. I do already know the coordinates of O because that's the origin. So that's 0, 0. So if I can find the coordinates of S, I can just use my distance formula. Now, personally, I didn't really do it that way. I did Pythagoras in that I made myself a little right-angled triangle, and I worked out the x-coordinate of S, and that was there, and the y-coordinate of S, which is there, and I did Pythagoras. But that's actually exactly where the distance formula comes from. So the distance formula is actually probably easier. So the first thing we need to do is we need to find this coordinate of S. Now, what we need to realize is that's a point of intersection. So I need to equate my graph. So my straight line is y is equal to x, and my hyperbola is g of x equals, let me just go remind myself, it's 2 over x plus 1 plus 1. Now you want to find a point of intersection. So I want to make these two y values equal to each other. And so there we go. Now, this is a little bit tricky in that I always like to get one term on each side, and I can't get one term on each side because there's 3 terms here. So it might be easiest for me to actually just say, right, I'm going to multiply every term by x plus 1. So that's multiplied by x plus 1, that's multiplied by x plus 1, and that's multiplied by x plus 1. So my x plus 1's land up cancelling, and on the side I get x plus 1 equals 2 plus 1 x plus 1. So now that's back to a standard grade 10 quadratic equation. So it's x squared plus x equals 2 plus x plus 1. So quadratic equation, get your everything to one side and one side equal to 0. So my x's actually end up cancelling each other, those two x's. And I have 3, so it's actually minus 3. Now that's just a very weird equation because, that's not a dots. And so I could use the formula to figure this out. Now if I really want to cut corners, I could say to myself, okay, so x squared would have to equal 3. Which means if I square root both sides, either it's positive square root of 3 or it's the negative square root of 3. Now I am cutting corners a bit there, and there's nothing wrong with that. Only other option would be to use the formula, and you'll get exactly the same answer. Now the question is, which one of these are S? Now S is clearly a positive value, so this is what's happening at S. This is the other point of intersection. That would be at negative root 3. So I know that S is the point root 3 something. Now how do I know the something? Well, very easily. It's on the line y equals x. So whatever x is, that's exactly the same thing as y. So I now know the point S is root 3 root 3. Now personally, I would now use my distance formula. So I would say the distance from O to S equals the square root of change in x, so root 3 minus 0 squared, and change in y, root 3 minus 0 squared. So that equals the square root of, now root 3 minus 0 is root 3. So it's root 3 squared, which is 3. And root 3 minus 0 is root 3. And root 3 squared is 3. So I land up getting an answer of root 6. Now, if they didn't say I had to write my answer to 2 decimal places, it's actually nicer to leave it in simplest third form. And root 6 cannot be written in any other way, and so root 6 is just root 6. So that was quite a mean question. As you can see, that was 5 marks, and it was very unseen for the matrics at the time. So the more we can expose ourselves to questions like this, which are different, the better off we'll end up being. Okay, and our last question for question 5 says, we've seen this quite a few times before, for which values of k will g of x equals x plus k have 2 real solutions that are of opposite signs? Now I remember this question from the matric exam very distinctly because it was a very, very difficult question. It was just very different. Now g is the hyperbola. So normally we have g of x equals k, and we've done loads of those, and we draw horizontal lines representing the constant, and for once that's not a constant. X plus k is a straight line. In fact, this is y is equal to x plus 0. That would be y is equal to x y is equal to x plus 1. This would be y is equal to x minus 1. So they're not actually saying where the hyperbola equals a constant. They're saying, when does the hyperbola equal one of these diagonal lines? When does it have two real solutions that are of opposite signs? Okay, well, first of all, let's look at the one that was drawn for us. This y is equal to x, which actually is y is equal to x plus k. The k is just 0. Does the hyperbola hit this straight line at two different points? Yes, it does, at S and at the other one. Are these of opposite signs? Yes, the one's negative and the one's positive. So immediately I can tell you that k is equal to 0 would work. Okay, so what else would work? If I drew in the line like I've drawn in y is equal to x plus 1, how many places does y is equal to x plus 1 hit this hyperbola? 1, 2 places. Are they of opposite sign? Absolutely. So actually k is equal to 1 would work. And in fact, anywhere between 0 and 1. So if I draw any horizontal line here, it would work. So actually, at the moment, the answer is anywhere between 0 and 1. Now let's look at the next one that I drew in. I drew in y is equal to x minus 1. Would that have two solutions? Yes. Yes. Of opposite signs? Yes. So actually it's turning out that there's lots of places where this works. Now if I drew any horizontal line, if I moved all of these horizontal lines down, whatever, how much I wanted, I would always have two solutions of opposite signs. So it looks like anything below negative 1 will also work. So where will it stop working? Well, if I draw lines above, that would have two solutions of opposite signs. That would have two solutions of opposite signs. When does it stop? When you go through 3, so this would be y is equal to x plus 3, you now have two solutions. One of those solutions would be x is 0, because that's where the graphs meet, and the other one would be somewhere here in the negative region. Now 0 doesn't have a sign. It's neither positive nor negative. If I go above that, I now am getting a negative solution there and a negative solution there. So I now have two places of intersection, but the signs of those points of intersection are the same thing. Now, what does that mean? That means your k value has to stop at 3. Anything below 3 will work, because it'll make any diagonal line anywhere going down, and that would have 2 points of opposite signed intersection points. But the moment I go above 3, both my intersection points have a negative solution. I can't do at 3, because at 3 I have 0 and a negative, and those aren't technically different signs. This was an incredibly mean question. It was very poorly answered at the time, and not very many people could get this right, because this would be considered as very, very difficult problem solving. And so again, if it's not something that you really like, that's not a problem at all. It's not something that most people like. But the more we expose ourselves to these things, the more we start to think. Right, that's the end of question 5. Just before I finish, just notice that that was 1 mark. So you know what, if there's 1 or 2 marks in a test or exam that you're like, I have no idea what's going on, it's absolutely fine. If you spent anything longer than 2 minutes looking at this question, we were now taking time away from easier questions that we could have gotten right. So don't get thrown by marks that you don't get, brush them aside and don't waste your time on them. Okay, only 1 more question to go.